Right. Now let us come back and solve your 2012 paper. So in 2012 paper, what do they give us? They've basically given us 3 complexes and we are supposed to find the name, okay, nomenclature. You have to draw the structure as well as magnetic behavior. 3 concepts together they've combined and given us to us. Let's start how to do this. First, let us write the name. When I have to write the name, I said you have to first be careful whether the complex is correct or not. That is what is important to you to analyze. So here they've given us platinum, they've given us 1 ammonia, 1 chlorine, 1 nitro. Always remember platinum, when I see it's going to form a hexadentate, means it should have 6 ligands around that, or it should have 4 ligands around that. Then only the valency gets satisfied. But here how many are there? 1, 2, 3, 4. Because with platinum PCl4, okay, it's going to form PCl4, right? In some other complexes it's going to form 6 ligands, but here only 3 are given, so you can directly write given complex is wrong. You can also write like this, right? So this, we can't judge this in case of its name and magnetic behavior. Let's come back and see this. So in this particular question, I have to write the name. Let's start. Always start with the ligand. Now this is the neutral ligand. How many are there? 4. So write on tetra. What is this? Amine. Come back to this, right? Dichloro. This is what? Cobalt. And I have to write the oxidation state. Let me calculate. And Cl is what? Chloride. Okay, let us come back and calculate and write the oxidation state in this. So here when I take this complex, what is this? I have to write the structure, magnetic behavior. For the structure, I'll keep it a bit aside, then come back to this magnetic behavior. How do I calculate magnetic behavior? Your cobalt atomic number will be given to you. So according to the atomic number, cobalt, I get 3d7 and 4s2. This is your configuration. Now come back to this. When I have to write the complex, CO, NH3 taken 4 times, Cl2 and your Cl. This is your complex, right? Now let's see. Now cobalt is X, ammonia is 0, this chloride is -2, this is also -1. So when this comes out, X becomes 3, isn't it? So your oxidation state is 3. Okay, let's come back and write 3. This is over. Now when I have to write the structure, let us keep this aside and come back to the structure. So for this, how to draw the structure? When you are drawing the structure, you have to first see how many ligands are present. 4, 5, 6. So 6 ligands present means it is an octahedral structure. Simple logic, isn't it? Count the number of ligands, that is your coordination number. The coordination number here is 6. So make the structure CO, right? NH3. So 1, 2, 3, 4, 5 and 6. Now start naming. NH3, 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 done. So 4, okay, 4 NH3s. So you have your Cl1, one more Cl1. This is done. And outer you have one more chloride present, which is a counter ion. Done. Now I am done with the name. I am done with the structure. I have to calculate magnetic behavior. Now come back and see how to calculate. Now this is your oxidation state 3. Now you have to take out 3 electrons from this. So what will happen? 2 are lost from here and your 1 electron is lost from here. So what will happen to this configuration? After losing 3, this becomes 3d6 4s0. Correct. Now fill the 6 electrons. You're going to fill the 6 electrons here. 1, 2, 3, 4, 5, 6. Is it paramagnetic or diamagnetic? Magnetic behavior they've asked me. Here all are unpaired electrons. Because they are unpaired electrons, I can call them as, or it is a paramagnetic substance. Simple logic, isn't it? Let's come back and see. First I have written the name. Then I didn't know what to write with the oxidation state. I came back with the atomic number. I wrote the configuration. With the configuration, I calculated the oxidation state. After calculating the oxidation state, I have written the structure, orbital filling. From that, I came to know that all are unpaired electrons, so I have written paramagnetic. And how did I write the structure? I have calculated the number of ligands. 4 plus 2, 6 in the coordination sphere. I made 6 and 1 Cl out. Simple. Let's come back and do the next one. How should I do this? Name it. Now this is your ligand. Name the ligand. This is tetra nickel. Okay, tetracarbonyl. I'm sorry, it is tetracarbonyl. Okay, now nickel right? I don't know the oxidation state, we will calculate. Complex, right? So let us come back and see this. We have written the name, isn't it? Now let's come back and write the oxidation state. So before writing the oxidation state, let us write the structure. How should we write? This is a tetrahedral structure and we are going to write nickel in the center. So tetrahedral shape would be one carbonyl above, one more carbonyl here, one carbonyl here, and one more carbonyl. So this is your tetrahedral structure. So now I have to write the magnetic behavior. How do I write the magnetic behavior? For that, you first come back and take the atomic number of nickel which is given to you. After the atomic number, you're going to write the configuration, that is argon 3d8 4s2. Done. Now start filling. Here this nickel is with which ligand in this complex? NiCO4, right? So there are two important characteristics of carbonyl. This is, first of all, this is a strong field ligand. SFL is strong field ligand. Along with that, this is a neutral molecule also. Both the concepts you have to be very clear. So when it is a strong field ligand neutral molecule, the charge on the neutral molecule is 0. Done. So what is X value? NiCO4 X value is equal to 0. So when the charge is 0, automatically I am going to write here 0. That means you will not write anything in the oxidation state. Tetracarbonyl nickel complex. That's it. Let's come back. Now I have to see whether it is paramagnetic or diamagnetic. Now when I have to see this, I say this is a strong field ligand. Okay, let us write. First 8, isn't it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 are done. Then you have 4s2. 4s2. So 4s2, now I said this is a strong field ligand. One electron from here is going to pair up with this. One more electron from here is going to pair up. So now what will happen? Your mu s is 0. The magnetic behavior has become 0. That means this concept or this particular molecule is diamagnetic in nature. That's it. So simple, isn't it? I've written the name, I calculated the oxidation state, I've written in this one, I've seen whether it is a strong field ligand or weak field ligand, and I've written the behavior.